Alright guys, they were solving exponential and logarithmic equations. Exponential and logarithmic equations. Let's go. Alright, property of equality for exponentials. If b is a positive number other than 1 and b to the x equals b to the y, if and only if x equals y. Hello. If b to the x equals b to the y, that can only be true if your two exponents are the same. The two bases are already the same. So if the exponents are the same, we're good. So like this one, if 3 to the x equals 3 to the 5th, x has to equal 5 because only 3 to the 5th can equal 3 to the 5th. So pretty much common sense there. Let's see how we're going to use it though. All right, a couple of equations here. It says solve each one of these. Now, the key to this is when you solve these, you must find the same base. You have to have the same base, and you just need to break them both down. Like this 4, for example, in this first one, is really 2 squared. So I'm going to write that 4 is 2 squared to the x. 1/2 is really 2 that's been flipped, so I'm going to write 2 negative 1 power. Remember, negative exponent flips things, so I have a power to a power. Multiply your exponents, that's 2 to the 2x. Over here, if you multiply the exponents, you get negative x plus 3. Now, your 2's are the same now, because think about the last slide. When the bases are the same, the exponents must also be the same for it to be equal. So I'm just going to forget the bases for a second and set the exponents equal. 2x equals negative x plus 3. Moving that x over, that's 3x equals 3, so x equals 1. And I promise you, if you plug them both back in up here, 4 to the first power is 4. If you plug one right here, 1/2 to the negative 2 power, you have to square it and flip it, it would be 4. It works perfectly. Let's try this other one over here. We have 100 to the 7x plus 1 and 1,000 to the 3x minus 2. Again, you got to have the same base to solve them, so I'm going to break them both down. There's a number that goes into both of them exponentially, and that's 10. So 100 is 10 squared to the 7x plus 1, and 1,000 is 10 cubed to the 3x minus 2. And you're going to be doing this a lot in class tomorrow, is multiplying these exponents because you have a power raised to a power. So it's going to be 10 to the 14x plus 2. Over here I'm going to have 10 to the 9x minus 6. And now you have the same base. You don't have to worry about the bases anymore. Just set the exponents equal. 14x plus 2 equals 9x minus 6. Move the 9x over, that's 5x. Same time I'm moving the 2 over there, make that negative 8. So x is negative 8/5. And that's all you got to do on that one. And those just find the same base and then set the exponents equal to each other. And that's all there is to it. All right, one more here, one that doesn't work out quite as nicely. What if you don't have the same base? Like what if you have 4 to the x power equals 11? There's no way to break the 11 down to a 4. Nothing goes into both of them. What you do when that happens and you need to find the exponent is you do log of both sides. So I'm going to do log. Notice I'm not going to put a base. I'm going to use base 10 because my calculator does base 10. I'll show you another way in just a second if you don't have a calculator. But remember the laws of exponent. The exponent always goes in the front. So I'm going to do x log 4 equals log 11. Then I'm just going to divide both sides by log 4. Log 11 divided by log 4. I'm going to punch that straight into my calculator. When I do that, I get like 1.73. That's the way I like to go. You could also use natural log if you want to. Some people like to do it this way. Let me come over to the side, change colors real quick. Some people like to use whatever base that number is that has the exponent. Use log of that base. So it'll look like this. It'll look like log. I'm going to skip a step. X log base 4 equals log base 411. That log base 4 is really just 1, so it's just x equals this, log base 411. Then you could use a change of base formula, which would be log 11 over log 4. And by the time you do all that, you've actually done the way I showed you anyway. So I'll just like to use the log base 10 and just go straight to the calculator. All right, if you have a log equation, all right, couple things here. If you have a log on each side, like with the same base, log base b x equals log base by, the only way that can be true is if x and y are the same number. An example here of log base 2 of x equals log base 2 7. X has to equal 7 to make that equation be equal. So we're going to use that property to solve some of these equations here. Let's try one. All right, log base 5, 4x minus 7 equals log base 5, x plus 5. Now, what I know for sure is the log base 5s are already equal. So what else has to be equal is what the number that comes after them. So I'm just going to set those two equal, basically just dropping out the logs. You're not really canceling them, they're already equal. So you take the other parts to make them equal. So I'm going to take the x over here, make it 3x minus 7 equals 5. Move the 7 over, it'd be 5 plus 7, which is 12. Divide by 3, you get 4. Now, one thing about these, you do need to check your answer because there's no such thing as a negative log. So just plug the 4 in, make sure it stays positive, and it does. So you're good, so. All right, this one, what if you just have one log? If you just have one log, you got to remember how to work out a log. And what you do, remember, is you do the base to that power equals that. Base 4 to the third power equals 5x minus 1. So that's what I'm going to write. I'm going to write 5x minus 1 equals 4 to the third power. Now, 4 cubed is 64. Everybody knows that. Move the 1 over. That's 65. Divide by 5, and you get 13. And again, plug it in, make sure it doesn't make the log negative. It does not. So there you go. So if there's one log, you gotta do the log. How to say that? You gotta work out the log. If there's two logs with the same base, you just say what number comes out to them equal to each other. One more slide. All right. I want to show you one that has an ln since I haven't shown you a natural log yet. So this is exactly the same rules because natural log is just a regular log just with base e. And because I have a natural log on both sides are already equal, I'm just going to take the numbers after the natural log and set those equal because they must be equal also, and solve that. So move the 2x over, that's 5x minus 4 equals 11. Moving the 4 over, make it become 15, and divide by 5, so you get x is 3. So that's all there is to it. Same thing you were doing anyway. No big deal there. Not a bad lesson. I'll see you in class tomorrow, and we'll work them out even more. See you then.